Good morning. A classical example of linear programming problem, dietitian problem. A dietitian has to develop special foods P and Q. Each food contains calcium, iron, cholesterol, and vitamin A at different compositions. The calcium from foods P and Q put together should be at least 240, iron should be at least 460, cholesterol should not exceed 300. The vitamin A content in food P and food Q are given. So how many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of vitamin A? Well, the number of packets of food P is X and food Q is Y. Then vitamin A in food P is 6X. Vitamin A in food Q is 3Y. Okay, 6X plus, say 6X plus 3Y. It has to be minimized. It has to be minimized. Then, subjected to constraints, 12X plus 3Y should be greater than or equal to 240. 4X plus 20Y should be greater than or equal to 460. 6X plus 4Y should be less than or equal to 300. Okay. So let us proceed to Python to solve this problem. A new file. So from module pulp import all methods. Okay, now the problem is a linear programming problem. So dietitian is the title. This is LP minimize problem. Okay, now variables X and Y are variables. X is a linear programming variable. Name is X. Its lower bound is 0, not be negative. Its category is integer. Similarly for Y. Y is equal to the name of variable is Y. Okay. Now let us define the problem. The problem, add objective function. What is the objective function? 6X plus 3Y. So 6 into X. 6 into X plus 3 into Y. 6 units of vitamin A in P, 3 units of vitamin A in Q has to be minimized. Next, 12X plus 3Y. Next is, there are 3 constraints. There are 3 constraints. The first constraint is for calcium. 12X plus 3Y should be greater than or equal to 240. 12X plus 3Y should be greater than or equal to 240. Second constraint, 4X plus 20Y should be greater than or equal to 460. 4X plus 20Y should be greater than or equal to 460. The last one is on cholesterol. 6X plus 4Y should be less than or equal to 300. 6x plus 3y. 6x plus 3y. Let us check once again. 6x plus 4y should be less than or equal to 300. Should be less than or equal to 300. Okay. Now print the problem to see whether LPP is formulated or not. To see whether LPP is formulated or not. Let us save this program. So LPP is formulated. Objective function is 6x plus 3y, which is to be minimized. Two constraints on calcium and iron. Minimum calcium required is 240, minimum iron required is 460 units, and cholesterol should not exceed 300. X and Y both are integers with lower bound as 0. So fine. Then solve the problem. So solution is stored in a variable by name status. What is solution of problem? Linear programming problem. The method is solve. So it calls simplex routine to solve the problem. Next, solution may be optimal or may not be optimal. If LP status of the status is optimal, then print the solution. Print. So vitamin A number of units of vitamin A in food P is value of X. Okay. Next, number of units of vitamin A. Number of units of vitamin A in food Q is value Y. Okay. Now, total number of units of vitamin A. Total number of units of vitamin A is value of the objective. Problem dot objective. Total number of units of vitamin A. Okay. Now, otherwise, print no optimal solution. Our optimal solution does not exist. Okay. So let us run this. This is problem. So vitamin A 15, vitamin A in Q is 20, total number of units is 150. It should not exceed 150. Okay. You can relax the constraints and see the solution. Suppose you need more calcium. Doctor suggested that calcium intake should be increased by 10. And how does it affect the final solution? Okay, no change in food Q, but food A changed by 1 unit. So total vitamin A required is 156. So you can check all your hypotheses, all your concerns with this algorithm. Hope you understand it. Thanks for watching, and please subscribe to my channel for updates. Thank you and good luck.